Yeah. I was thinking I didn't have to bring my jacket to school anymore, but
No.
not quite.
Well, then the school's hot. But then outside, I can see the minutes.
Some years we get snow on spring break though, so
That is true.
hopefully not this year.
You don't want some more snow days?
During spring break?
Or after?
I don't like snow days. My wife has to go to work either way, so
Oh.
if I get to stay home, then I also have to be guilty, so.
Yeah. Is this a new set of questions?
It is, but we won't get through all of it today.
Okay.
Is it quality though?
Well, it's just a rough draft. It's not bad. Let's just say the drink from
Good morning. I need you guys to number today's handout as 94. You will also want a calculator, and you're also going to want a blank piece of paper here in a bit. So if you want to go ahead and get all that sorted out. We are going to be moving into the last of our logarithm. stuff. And in this section we practice solving equations. So you can see from that book assignment, it's a very long book assignment, but it's not something we're going to try to get done in one day, but it does certainly warrant quite a bit more practice to be good at. And to be truthful, being able to work with logarithms and simplify logarithms and stuff like that is also good for science courses. Really, the main reason that logarithms are good for math class is solving equations. So as far as math is concerned, this is really what we have been building up to the last several weeks. So again, this is a section we won't just fly through. Very important that we all understand what's going on and get pretty good at this. Okay, but first off, we need to look at some notes. So in my notes, I'm going to the thing with solving equations is there's a lot of different kinds of equations and there's a lot of different strategies that you can use. So with the notes, I kind of start you off as easy as possible, and then we're going to slowly add to that until you've got everything down that you need to do. Okay, so specifically, the thing that makes logarithms important and what we care that they can actually do is, in the end, we want to be able to solve exponential equations. What is unique about logarithms is that it's the algebraic way to solve exponential equations. So there's a lot of real-world functions, formulas that have variables in the exponent, and if you ever want to solve for those variables, then logarithms are necessary. Now, while that may not happen a lot in your day-to-day lives, someday you may have a job that expects you to be able to do things like that. Okay, so again, starting off as easy as possible. Sometimes you don't need to really get out logarithms. A lot of times you can just work these in your head in one quick step. So something like question 2, I would hope that you wouldn't feel like you need to do any of this other stuff we're going to talk about, because 5 squared gives you 25 and 2 to the 4th gives you 16. Just be careful not to accidentally multiply. You're doing exponents. I guess question 4 and 5 have logarithms, but as long as you still know how to read these. This is saying 2 to what power gives you 8, and 3 to what power gives you 9. So you will see that sometimes. I think even our test probably has one like that where you don't have to do anything fancy. It's very straightforward. Okay, other times we need some other strategies. So like the answer to question 6 and 7 and 8, those are not nice whole numbers. Those are not things that I can just do quickly in my head. So the first technique, and we have had to do this just a little bit, but we're going to be doing it quite a bit more now, is change the form. If it's in exponential form, we're going to switch it to logarithmic form, and in a minute we're going to go the other way. So if you have an exponential, you can switch it to logarithmic form. Remember, to switch it to logarithmic form, you need to put log out front, and then these two things switch places. Well, I guess on this one we would normally say natural log of 5, but if you leave it log of base e, that's the same thing. And sometimes that's enough. So moving this to logarithmic form would make them look like log base 10 of 3 equals x. Well, you know what x equals, so it has been solved. Exponential form, sometimes switching it to logarithmic form is all that needs to be done. So that's one of the first things that I consider. If I was to switch to form, if it's helpful, then I'm going to do it. If I'm not sure, I'm going to do it and see. And I guess if it's not helpful, I got to do one of these other things. Okay, so same questions for 9, 10, and 11, but I want to show you that there is an alternate method, and sometimes this method is necessary, so it's good for you to know that you can do this. You can take the log of both sides, or the natural log of both sides, and that's okay because it keeps your equation balanced. So in this one, I'm just going to do natural log on every question. In calculus, we always use natural logs instead of regular logs, so since it doesn't really matter. So taking the log of both sides is what is kind of different here. And then you've got to apply some of these properties. You got to know that you can bring this x down. You have to know that the natural log of e is 1. Question. But notice, same question is over there, different process, but same answer. So sometimes you might think this is easier, and sometimes this is going to be necessary, so you need to know that it's a possibility. Okay, over here, you could do the log of both sides or the natural log of both sides. Honestly, log is probably better because this is a 10, but technically it doesn't matter. Your answer can look different and still be equivalent, which is why the calculator is going to be important today. But notice I took the log of both sides, which is algebraically okay because I'm doing it to both sides. I can simplify this using the log properties. Bring the x down. If there's no base written here, it's an understood base 10. So all of this becomes 1. So the answer to this is log of 3, which is the same thing we got by switching the forms. Okay, and then in 11, again, it doesn't really matter, but I'll do the natural log of both sides. And then because x is an exponent on something we're taking the log of, x can come down out front. Undo times with divide. And then you have x equals, so you're welcome to circle your answer and move on, although it's really a good idea to check it. But notice this looks different than my answer in number 8, even though it was the same question. Do you guys realize that these two are equivalent? If you know the change of base formula, then you should know those are the same thing. Sometimes you might type this in your calculator by typing it in this way. That's the change of base with the e. So sometimes your answers can be the same and you may not know by glance, but that one you should know at glance. So even though this taking the log of both sides is probably the least common strategy we're going to use in this section, it is necessary on a couple of questions. So we got to keep that in the back of our mind. So if switching from exponential form to logarithmic form sometimes solve our equation, then sometimes going the other way is going to be good. If you're in logarithmic form, consider switching it to exponential form. So to review that, if you want the log to go away because exponential form is not going to have log in it, you've got to switch these two. Natural log means log base e. If you want to switch the form, the -7 and the x switch places. But then if you have x equals, you are finished. Switch the forms. Technically this one has one more step, but it's an easy step at least. Switch the forms. And if you know what x equals, then circle it and move on. So we've already talked about 4 strategies that we need to consider, and we need to kind of keep these in mind as we go along. So the first question type we looked at were ones that were easy enough we could do in our head. The second question type we looked at was switching from exponential form to logarithmic form. The fourth type of question that we looked at was switching from logarithmic form to exponential form. And then the other one, probably the least common one, is taking the log of both sides. Okay, so moving on, now we're going to slowly start to inch out to what the questions will build up to in the book assignment. So I still think it's a good idea to start with that stuff, but sometimes you're going to need a step or two of basic algebra to finish the question. So when I look at question 16, I still would say, let me switch this to exponential form. So take away the log, switch 3 and 2x minus 1. Now, unfortunately, I don't know what x equals, but what's left over is just a couple basic algebra steps. Undo a minus 1 by adding 1 to both sides, undo a times 2 by dividing 2 by both sides. Makes the question a little bit longer, but it's certainly not harder. Okay, if we switch the forms here, this is exponential form, so logarithmic form would look like this. And since I don't know what x equals, I need to keep going. But I would just need to undo times 3 with divide 3. So I'm still switching the forms. It's just that I'm undoing add, subtract, multiply, or divide after. Okay, 2 more. If it's an exponential form, try putting it in logarithmic form and then solve for x. If it's in logarithmic form, switch it to exponential form, and if you got more work to do to solve for x, then do that. This one way I can actually simplify. This would be 100 minus 7, so 93. So just because you switch the form may not be enough. Consider also undoing add, subtract, multiply, or divide. Okay. You guys okay up through 19? You got a question back there?
What is the first number that you have written on 19?
This?
Yeah.
10 squared. Since there was no base here, that was an understood 10. So when I switched the forms, it became 10 squared equals x plus 7. And then I said 10 squared was 100, subtract the 7 over, which made it 93. Okay, so just like you could undo, add, subtract, multiply, or divide at the end of a question, sometimes you need to do it at the beginning of a question. So that's the next little set. If it's not set up to switch from, if it's not in exponential form or logarithmic form, you might need to undo add before you switch the forms. Maybe undo times before you switch the forms. Another undo add, and then switch the forms. Now normally I would change log base e into natural log, but since it's equivalent, just kind of going along here. And maybe undo multiply before you switch the forms. Divide both sides by 7, switch the forms, and then it's finished. So if there's add, subtract, multiply, or divide, to get it in logarithmic form or exponential form, do that first. If there's add, subtract, multiply, or divide to undo to finish solving for x at the end of the question, then do that. And then some of the harder questions are going to require both. So I'm undoing some algebra at the beginning and undoing some algebra at the end, and somewhere in the middle switching the forms. So for 24 and 25, the basic algebra that needs to be undone is divide both sides by 2, divide both sides by 4. So that would be 40, 20. Then once it's in exponential form or logarithmic form, you can switch the forms. And if you have x equals, you're done. But if you don't have x equals, you may need to undo some more arithmetic. In this one, divide both sides by 3. Over here, divide both sides by 5. But really the big the big logarithm step in there is the switching the forms. But you can't just switch the form at the start of those. Those are not written in the correct way until you divide both sides by 2 and divide both sides by 4. Okay, combining with what we learned last class, I think I threw one at you in the notes to kind of give you a heads up on this, but one thing you sometimes need to do, if I'm looking at 26, none of the stuff I said on the front page applies here. There's no basic algebra to be undone. There's no, it's not in logarithmic form or exponential form, so I can't just switch the form yet, so we need to do something else. Sometimes you need to expand or condense your logarithms to move forward. So, like these two are both log base 2. If they were separated with add, then you can condense them with multiplication. And then you can do what we did on the front page. You can consider switching the forms, see if that helps. If there's add, subtract, multiply, or divide at the end to solve for x, then undo it. But when we get to your next 50-point test, which I'm guessing is now, not going to be before spring break, we'll probably have to come back and review a day and then take it. But we will certainly have a few questions on there where we just simply ask you to expand or condense to see if you can do it. But then there may also be a couple questions that are solving equations like this where it's the only way to move forward. Okay, and then based on what we talked about yesterday, the only other way to condense for question 27 is with subtract. These have to be the same type of logarithm. Subtraction condenses into division. But if you consider doing that, and you can do that correctly, now it's in logarithmic form. You could switch it to exponential form, and then undo times 3 with divide by 3. Or undo divide 3 by times 3, I mean. Yeah.
Can you fully solve that?
With a calculator maybe, but 7, do you know what 7 to the 7th power is?
Well,
I don't-
just like, if we had a calculator, we would put it in.
Yeah, if you had a calculator, you might as well. But 7 to the 7th power is going to be really big.
Will you like dock points if we keep like that on the test or no?
No, it's fine. I mean, it's the same thing.
Yeah.
3 times 7 to the 7th is this. If you had a calculator and you wanted to type it in and write this as your answer instead, that's fine too. But I certainly don't expect you to know what 7 to the 7th power is in your head. Maybe if I gave you 30 minutes to try to do it on with pencil paper, that might be fair, but okay, one more, because this one doesn't fit. I don't really know why that one's in there, but if you don't see anything else and you're not sure how to start the question, it may be that you need to condense these. They're both natural logs. Addition condenses with multiplication. You might need to do that step before you can switch the forms. And finish solving for x. Now back to the question you guys just had. I would not want you to put this one in your calculator. This would be some decimal, and unless the question says round, you're spending more time to go to your calculator, and then you're giving me a rounded answer, which is not as good. I prefer the exact answer. I prefer you to quit early. So expanding and condensing can sometimes help us get it into logarithmic form or exponential form so we can switch them and solve the equations. Okay, 2 of the question types that we had asked you to do before are still going to be fair game in this lesson. So If this is log base 2 and this is log base 2, we just need to make sure that the insides are equal. You do have to check to make sure it's not extraneous. So you can have negative answers, but you can't take the log of 0 and you can't take the log of a negative number. You have to consider plugging it in and make sure that that doesn't happen. That one's fine because that gives you log base 2 of 5, and 5 is a positive number. And then the other one that you did on the first half of your test is sometimes you've got to simplify using log properties, like knowing all of that is 8, and then you can finish solving normally. So this section throws a few of those at you, not very many, but still good to keep that in mind. Okay, and then kind of the last of the techniques. Also, not many of these question types, but this just doesn't fit into any of the other strategies that I told you. It's not ready to switch forms. There's no basic algebra that can be undone. I can't expand or condense logarithms. I don't know. It just doesn't fit anything else. But if you see something that looks like this with 3 terms, the way you want to move forward on this is with factoring. So again, factoring, most important thing you guys should have gotten out of Algebra 2. If you have to slow down and do product sum method or something, then please do. But e to the x times e to the x gives me e to the 2x. I'm just trying to unfoil it. Negative 4 times negative 1 multiplies to be positive 4. And if I foil my answer, the outer combined with the inner would be minus 5 e to the x. So that's how that factors. Then just like with quadratics that you solved in Algebra 2, if this times this equals 0, either this could equal 0, and you get answers for when this equals 0. This one you have to solve, switch the form, and then one of these we could simplify a little bit more. Do you know what the natural log of 4 is? Do you know what the natural log of 1 is? Huh? 0. So we can make that look a little bit nicer. So you have to know that when it looks like that, factoring is the way to move forward. Again, not a lot of those, but enough. I think we do put it on the test too. Okay, we still okay? Okay, I want to show you one real life example. I want to talk about how to check your answers, because some of these questions, your answer may look different than the back of the book, and your answer could still be fine. So I need to make sure that you know how to check that. Okay, but first, our real life example here of why you would want to be able to solve something like this. So we did these compound interest formulas. So compound continuously was the PERT formula. And in 3.1, when we did this, we gave you the starting amount P, we told you the rate, you had to change it to a decimal, we told you how long it would be, you plug that in for time, and then you could either type it in your calculator or pick the answer that matched up with that. But in this question, we know how much we're starting with, 2,000. E is a number, not a variable. The bank's going to tell you what they're going to give you, 2%. They're actually giving a little bit higher than that now, not much though. And realistically, you probably want to know, I'm saving up this money for XYZ. I know I need this to become $6,000 for whatever I want to do for it. And what you don't know is how long do I have to wait? What is the time? And while in this exact example, if you were saving up for a car, you know, you don't have to know to the exact minute of how long you're going to have to wait. So it doesn't seem like, you know, an estimation would be plenty. But someday you're working for a business and they need stuff to be as efficient and precise as possible, and they're expecting you to be able to do this stuff. You've got to be able to solve for this exact value. Exactly how long do I have to wait for my $2,000 to become $6,000 if it's compounded continuously and I'm getting a rate of 2%. So we got to apply the things that we talked about on this handout. If there's any basic stuff to be undone, like undoing times, do that. You don't have to switch these two, but the next thing I would do is switch it from exponential form to logarithmic form, and y'all tend to do a better job if this is written over here. So and then finally, I don't know what t equals, but I can with division. So the exact amount of time that you would have to wait for your money to triple, your $2,000 to become $6,000, would be the natural log of 3 divided by 0.02. Again, maybe a little more accurate than you would actually need in your real life, but so almost 55 years. So if that's your plan to get your first car, you're probably not wanting to wait 55 years. You better keep saving up some money or something. But really, any exponential function, anytime you're solving for a variable in the exponent, there's no other algebra tricks, techniques, rules, properties, theorems, anything for you to solve for a piece in the exponent besides logarithms. That's where logarithms really come into place. Okay, now to check your answers, because again, depending on the approach that you guys take, your answers can look completely different and both can still be correct. Now that's a pain for me when we get to the test, because if your answer doesn't match with my answer, I have to investigate and see if your answer also works. But when you're practicing and you need to know if you're doing it correctly, and I can't work every question the 5 different ways that you guys might get your answers to look like, this is what you need to do to check your answers in that case. You need to remember how to store this in your calculator. So we'll just use this one as an example. And I'm just going to store it in, you can store it in for x or for t. I guess I'll store it in for t because that's what I solved for. So in your calculator, you would type in what you think the answer is. Use the store button near the bottom left. It's right above on. And then you can store that in for any variable you want to. I usually do x because there's a button right here for x, and that's just quicker. But since we really solve for time, you might want to do alpha 4 to store it in for t. So now anytime I say t in my calculator, alpha 4, it's not using a rounded value, it's using the exact value. It's keeping up with it for me to know that it's exactly perfect. What that was supposed to be the answer to is it was supposed to make this a true statement. So 2000 e to the 0.02 times t, it's supposed to equal what? So if you hit enter and you don't get 6,000, your answer is not correct. If you do hit enter and it equals 6,000, even if your answer looks different than the back of the book or how I do it on my website, it is perfectly fine. It can look slightly different and still be equivalent. So that is one of the best calculator tips I can give you guys as well, the store stuff. Even on the ACT sometimes, like since it's multiple choice, occasionally it's quicker to just store an answer, plug it in and see if it works, and if not, store answer B in, see if it works, store in answer C, see if it works. Sometimes that's quicker than actually working out the math, and it's pretty quick with your calculator if you practice using that. Okay, so any questions that jump out at you from the notes? Any of these techniques you want me to quickly discuss again? Okay, at the bottom, I know I verbalized all this, but again, it's kind of a lot to keep up with until you practice it and start to solidify exactly what you know you need to be doing. But this is the order that we kind of did things in. We did a few where we could just do them in our head, so that's always my first thought process. I'm hoping it's that type of question because it's short and sweet. Sometimes we can just use a quick little logarithm property, and then that's enough to solve it. If there's any basic algebra that can be undone, like add, subtract, multiply, or divide, I'm going to do that. If it's in exponential form, I'm going to consider switching it to logarithmic form. If it's in logarithmic form, I might consider switching it to exponential form. There's those questions that all you can do is factor. So if it's got 3 terms and it looks like that question type, I need to factor. If none of that stuff is helping, could I expand or condense my logarithms? And if that helps, then that's the way to go. And even if you do one of these things, sometimes you got to go back and consider the other. Sometimes you have to undo some basic algebra before you can switch the forms. So you do those, you got to consider them again. Make sure your answers are not extraneous. So like those questions that we did without just using properties, you have to plug them in. Make sure you're not taking the log of 0 or log of 0 or a negative number. And then finally, make sure you know how to store it in your calculator so that you can check the original equation. So that's how I would summarize. That's a list of things that I would consider on each question until I feel like I knew what the mental process is going to be. Can I do it in my head? Is there any basic algebra to be undone? Can I switch the form? Does it look like it factors? Does it look like there's basic properties to be used? If I did some of that, can I now do something else? If I did it by hand, I need to make sure it's not extraneous. And if my answer looks different than the back of the book, I need to store it and make sure that it works before I assume that's good. Okay, so as I said, we got a long book assignment because this does take a lot of practice before we get to the level we need to be at. So on your blank piece of paper that I asked you to get out, if you go ahead and copy that assignment down, and then go ahead and try the first couple and see how they go. And then I'll check back in with you and start helping you where you may be getting stuck. Of course, some of the first questions should work out a little bit quicker unless you don't know how to start them. But roughly, I would be happy if we get about half of this book assignment done. Half would be a good start. So don't be intimidated by the number of questions. So any of these first few that you guys get stuck on, just be quick to skip it and be ready to ask when I ask for some questions. Don't spend several minutes on any one of these first few. Okay, let's do a quick check-in over the first 7 questions. Okay, any part of number 1 that you're not sure about? I had 4 different parts. Huh? Oh.
Can you do 1%?
Number what?
Can you do like all of them?
No, I'm not going to do all of them. I will help you with the ones that you're not sure about. I'm not going to do it all for you. Which part of number 1 are you unsure about?
Can you do 30?
Everybody's okay with 1. 2, everybody knows what the word is they're looking for there?
Yeah.
No? That's extraneous. An extraneous solution does not satisfy the original equation. Okay, question 3 is not asking you to solve, it's asking you to check. So if you were to solve this and you got an answer of 5, they're basically asking you, do you know if this is actually correct? Did you do your work correctly? So you should be plugging it in. This would be 3 is 4 to the third 64. So this one's a yes, that is a solution. For B, what if you got an answer of 2? Well, if you plug that in, it would look like this. Is 4 to the negative 3 the same thing as 64? Nope, so that is not a solution. And then C looks kind of crazy. But sometimes our answers are going to look that way. So we got to figure out if this is the same thing. So you could distribute your 2 here. You're going to need to evaluate this. 4 to what power gives us 64? We did that right here, 4 to the third. So all this becomes 3. So we get 7 plus 3 would be 10. Is 4 to the 10th power 64? No, then that is not a solution either. So they're not asking you to solve anything on number 3. Just if you got those as answers, do you know how to plug them in and see if they work? Also good for you to check to see with the calculator. Okay, what was after that? Number 7? Was that the next one? Okay, anybody need help with number 7? Okay, what about number 8? Okay, did y'all get to number 9 yet? Number 9 should be an easy one, so if you don't see it in about 5 seconds, you need to ask. Okay, let me give you a little bit more time then. Okay, I know I checked in recently, but as these questions start getting harder, anything that you don't consider doing is going to quickly become a problem because you're going to start to need it in a lot of questions. So number 9, 10, 11, 12. 13, 14, 15, 16, any of those you'd like me to help you with? Okay, most of those are just switching the forms, and that should be enough. So, okay, I will check back in again. Again, these first ones you shouldn't be spending too long. Please don't be spending several minutes on any one question yet. I'd rather you skip it and just ask. Yep.
I don't know how to solve from there because I can't.
Yeah, that one is one where you need to take the log of both sides.
Okay.
So do like natural log of this side and natural log of this side.
Okay.
That's all you could do on that one.
Oh,
So
okay.
you
Okay.
put it in
Never mind.
solid,
Alright.
becomes natural, and E, that creates 1 times X plus 1. So it's just X plus 1 equals. That is
I'm gonna go to 2 instead of this would be 2. And like then -5.
Okay. What? I really just started 13.
All right. Have you guys found a few I can help with yet?
You did 17.
Yes. So 17's not really a hard one to solve. So this is F. But what they're trying to get you to see in question 17 is that if you're solving this, if you're solving this graphically, when f is equal to g, it would be when x equals 3. So graphically, when you solve things, when they intersect is when the solution would be. And then the other part of the question is do it algebraically and solve it algebraically, and then just based on those numbers, we don't even need logarithms for that. So they're just trying to get you to see what you're doing algebraically versus what it would look like graphically. Hmm? Have y'all gotten to, I guess you don't have to do that. Number 20. Okay, in 20 you have e to this equals e to this. So this part's already equal, right? The bases are already the same. So all you really need to do is make sure that the exponents are the same also. So set the exponents equal to each other. This is a quadratic. You always put everything on one side equal to 0 when you solve a quadratic. You're going to hope that it factors because that's the quicker path. Unfortunately, that one did not factor. Did you make it that far?
Yeah.
Okay. So the only way to always solve a quadratic when factoring fails is quadratic formula. So put an opposite of b, plus or minus square root b squared minus 4 times a times c all over 2 times a. Simplify this. This would be like 1 plus 4, which would be 5. So it looks like that's your two answers. So using quadratic formula is not my favorite, but based on the number, a was 1, b was -1, c was -1, it actually worked out pretty nicely. It didn't take that long. But the first step is important. Understanding that if this is e to something and this is e to something, that part's already equal, so you just need to make sure that the exponents are equal too. Okay, 2 more, and then I'll get out of your way again for a few minutes.
You do 15 once you remember that.
15? Sure.
Yeah.
15 is in logarithmic form. And if you switched it to exponential form, these two would switch places. So I guess you can leave it like that, but 4 times 4 times 4 should be 64. So all you have to do is switch the forms on that one. Okay, one more for now. Okay, I will check back in again before class is over. But again, you will need to do the whole assignment at some point, so try to get as much done as you can. Of course, the end of the assignment, the questions are going to be a little bit longer. So something else to keep in mind. guess I should also add, as you guys get the questions that you miss, or you need to look at your notes at, or you needed me to go over it to give you a hint, I would say in this section, I always recommend this, but giving yourself some notes, write out to the side what you didn't do, what you didn't consider, highlight that is going to be more important than normal. Since it doesn't look like we're going to be able to squeeze in the second half of this test before spring break, when you come back from spring break, it's great that you do this practice, but it would be much better if you had this practice and out to the side you have 4 or 5 notes to yourself about what mistakes you were making, what things you didn't consider, what properties you forgot. That would go a long way to making sure you were back on track to test. So we definitely wouldn't test you the first day we come back from spring break, but it will probably be the second day when we come back. And you don't want to start from scratch. So. Okay, is there another one or two I can help with?
Uh, 40.
Number 40. Wow, okay. Okay, so looking at question 40, again, I'm thinking about the bottom of the notes because that's what I try to summarize in my head as my things I need to try. I certainly can't do this in my head. I can't just switch the forms, bless you, because this is not exponential form, it's not logarithmic form. I can't just undo, add, subtract, or divide, anything like that, because that stuff's up in the exponents. These bases are not equal, so I can't just set the exponents equal to each other. I can't factor this one. I can't expand or condense. But there is one thing in their notes that does help us out here, that even though all the other ones don't. And it is taking the log of both sides. If you consider taking the log or the natural log of both sides, then this is an exponent that can come down. This is an exponent that can come down. And that's a vast improvement because at least what we're solving for is not stuck up in the exponent anymore. This is just a number, so I'm going to distribute it. This would be like 6 natural log of 7 minus x natural log of 7. Did you make it this far by chance? Okay, good. That's the important step that a lot of times y'all don't think of because you don't need it very often. Now, to be fair, this question's a little crazy to finish. This is very uncommon. But this is a quadratic. The biggest exponent's a 2. Again, this is just a number. So I've got some x squareds, some x's, and a constant. But anytime you solve a quadratic, you want everything on one side set equal to 0. And then to solve a quadratic, most of the time you get away with factoring. But if you can't figure out how it factors, or if it doesn't factor, your only option is quadratic formula. And again, this one's just kind of crazy. But a would be the coefficient of x squared. B would be the coefficient of x. And C, the constant, would be that. Now, I will tell you that we're not going to throw a bunch of quadratic formula stuff at you on the test, but there might be one. So it's good to make sure you know it. Throw this in for B. Throw that in for B again. Throw that in for A. Throw this in for C. And I'm going to take the -6 times the -4 and make it a positive 24. I'm just going to go ahead and multiply those. All over 2 times A again. And even though that is pretty extreme, there's nothing you can really do to simplify that. So there's your answer. A, B, and C plugged into a quadratic formula. But as you guys are moving along here, you should be seeing that lots and lots of your answers look pretty crazy. You should not be expecting nice whole numbers in most of your answers. You can't just hope to look at your answer and have an idea if it's correct. So I'm guessing quadratic formulas where you got stuck at, or you didn't think about using it. So again, pretty extreme example of quadratic formula, but if you know quadratic formula, you know where A, B, and C come from. Basically, I just plugged them in, and the only arithmetic I did was right here. I said -4 times -6 is positive 24. That's the only real simplifying I did in that mess. Okay, can I do one more? Is there anybody who's not asked a question today yet? I can give you a chance before everybody else. It can be any part of the assignment. If you made it far, that's great. If it was something early on that you weren't sure about, that's fine too. Yes.
38 also a quadratic formula, like as a sort.
38. know, give me 2 seconds to. I don't think so, but. I don't know. Maybe I'm just not looking far enough ahead. No, that one can't be quadratic because it's not quadratic. Your biggest exponent's 1. But what you can do, did you get near this? Okay. So, since this is linear, you should move all of your x stuff to one side, all of your constant stuff to the other side. So this needs to be subtracted over, this needs to be subtracted over. And then normally, on much nicer looking questions, you might have something like 8x minus 2x, and you could change that to 6x. Here I've got 1x minus the natural log of 2x, and I don't know what that is as a decimal, and I don't want to change that anyway. But what you can say is both of these have an x, so you could factor that out as a GCF, and then you can undo times with divide. So no exponent of 2, so not quadratic formula. But was still a little bit harder to solve for x in the end. Okay, now I don't have every one of these worked out on my website, but I do have the vast majority of them. So if you feel like you're struggling and you need to put in a few minutes outside of class between now and Tuesday, then please utilize the website to help you feel like you're getting caught up with at least how everyone else is doing. But to be really clear, you guys do not have to finish the book assignment yet. Sorry, do you need this back up? I do not expect you to have the book assignment done on Tuesday. If you think you're behind, do a few more. If you think you're about where everybody else is at, then just wait till Tuesday and we'll move forward from there. Okay, you'll have about 3 minutes.